So now that I've given you an overview of how we're applying ChatGPT for static code analysis, let me actually show you how I'm using ChatGPT in order to be able to analyze my student programming assignments and be able to mark them and assess them in a systematic way. So you can see I've opened up my browser to chat.openai.com, and I've created a version of ChatGPT-4 that uses the default setting. We're not going to be using the advanced data analysis portion because that has some bugs when trying to parse Java code. So we've now switched over to my Emacs editor. I love Emacs. I know it's probably a character flaw, but I've used it for about 40 years and I find it very effective for what I need to do. So let me show you the scripts that I'm writing for use with ChatGPT. And we'll start out here by taking a look at one of the scripts. This is for a file that's called the fork join crawler class. And this is my assignment. My assignment is using the Java fork join framework in order to write essentially a web crawler that will be given a URL to the top of a recursively structured directory hierarchy. And then it will just crawl from there down and try to visit all the links and download the images and so on. So I want to see whether my students' code is correct relative to my assessment of their frequently made mistakes. So I write this prompt and I start out by giving it some instructions. I say, please read the Java fork join crawler class. And that's everything between the tags code start and code end below. Strip out all the comments, parse the Java code using your most advanced method to identify the class constructor and methods. And this is because I want it to really understand how to parse the code. As it turns out, using ChatGPT-4 with cutting and pasting this into the code window, the chat window, works great, get very good results. Oddly enough, using this with the advanced data analytics doesn't work at all. And that's because for some strange reason, ChatGPT-4 at the moment tries to use Python code to parse the Java code, and they don't have a good Java parser in Python. So that was learned through the School of Hard Knocks. Then I also give it some other hints to make sure it's actually interpreting what I give it, the code I give it correctly. So I say, I want you to look for certain things that correspond to this signature form. So I say the name of the class followed by the signature of the method. And then I list out the name of the class, which is fork join crawler, and all the methods that I want ChatGPT to find in that code. That again provides it with the right context to accurately parse the code, analyze the code, store it aside so it can answer my questions. I then give it another prompt, another part of the prompt where I say, summarize this class, its constructor and methods with what's called temperature 0.1. That means be very precise. Don't start trying to be creative. I want it to give it very precise answer. And store all these information in an internal data structure so you can analyze it and then print your detailed responses to some questions I'm going to give you. And then I tell it to apply a 4-step method before responding to the questions below. So I say, carefully inspect the code line by line and print summaries of what it's doing before answering the specific question. Give line numbers and method names wherever possible to justify your responses. Don't give me yes or no responses without double checking, and ask me questions if you don't understand something. Now, ChatGPT is a little bit flaky in some of this stuff, but it does a pretty good job when you give it these kinds of prompts. Next, what I do is I give it a list of questions. These are things that are based on my review of my students' solutions, initial solutions, and I'm going to ask it questions. Some of the questions are things the student solution should not do, and other things are things the student solution should do. And so historically, people either do stuff they shouldn't do, or they don't do stuff they should do. And these questions are meant to provide answers to that by querying and using ChatGPT as a static code analyzer. So here are some things that the code shouldn't do. They shouldn't be calling the fork method explicitly in the perform crawl method. They shouldn't be calling the join method in the perform crawl method. They shouldn't be calling the submit method anywhere. These are all fork join methods they should not be calling. However, they should be calling the common pool method in the perform crawl method, and they should also be calling the invoke method after they call common pool. So these are things they should do. There's a bunch of other stuff. They should not be creating a new fork join instance. They should use the common fork join. They shouldn't be shutting down the fork join pool. I want them to not use try catch blocks. So if they use a try catch block, I want ChatGPT to flag that and tell me the line number where the block appears so we can give them comments and maybe take points off. I don't want them using things like atomic references or atomic integers. There's a bunch of other stuff which has to do with whether they're accessing fields incorrectly. I want them to stay away from index-based for loops and instead use Java for each loops or use Java for each methods. I want them to only use a method called call in manage blocker in specific places. So I say, where are all the places you use it? And then I can see if they call it more than once. I want to make sure that they're calling methods that are part of the collection interface, such as the hash map, that are thread safe. So if they call non-thread safe methods like contains or equals, I can flag that and mark them down because they shouldn't be doing that. I want them not to use Java streams in this solution. Subsequent assignments will have them using Java streams, but not here. And then I want to make sure that they're calling the call and manage blocker method in a specific place. And I want to make sure that they're using special syntax using the constructor reference URL : new in the context of the rethrow function exception utils exception laundering mechanism. And then here's a really interesting thing. I want to make sure that they don't do variable plus equal 1, but instead do variable plus plus. So it's actually going to be smart enough to look at the code and find cases where they use some other name like image count plus plus or image count plus equal 1, but I've given it a more generic description. ChatGPT is smart enough to infer what I'm asking it to do. So armed with all that, I then give it the code. And just for fun, I'll show you some places that the code is incorrect. This is based on my students' code. They're making a new fork join pool. They shouldn't be doing that. They should use the common fork join pool. They're shutting down this pool. They shouldn't do that. They should be calling invoke not on their private pool, but on the common fork join pool. That's something they should be doing, but they're not. If you look down here, you can see that in this method, they're using a try catch block, but they shouldn't be doing that. I want them to do something else. And if we go down a little bit further, we'll see those are basically the problems with the code. So let's cut and paste this, and then we'll switch over to ChatGPT. So here we are in ChatGPT. I always start off a new chat window, and then I cut and paste the code in there. That way we don't have any leftover context from previous uses. And you can see I cut and paste this into ChatGPT. And what it then does is it goes ahead and it reads this code. And the first thing, which I asked it to do, is it will give us a summary of the method signatures that are in this particular class. And that's important because that way I know what it was able to interpret when it parsed the code. This is where you'll have problems if you try to use ChatGPT with the advanced data analytics. It doesn't parse the methods properly. So now we start taking a look at its responses to my questions. So I said, is the fork method invoked? And it looks at the code and it says, no, it's not invoked. That's good. And you'll notice it also double checked things. Is the join method called? It checks no, that it's not called. That's good. Is the submit method called? No, it's not. That's good. But now it's going to notice that there's no use of common pool, which there should have been. And so that's an error. We would take points off for that. Likewise, it noticed that there was no use of common pool followed by invoke. And so that's another thing to take points off. Does any of the provided code create a new fork join pool? Why, yes, it did. That's an error. So that's a mistake. Did the code call shutdown on the fork join pool? That's an error too. Take some points off. Did the code use a try catch block, which it shouldn't? It found where the try catch block was found, and it tells me the method that it occurs in. And it also checks to see if there were atomic references. It checks to see if there was access to fields that it shouldn't have accessed. It checks to see if there was any use of index-based for loops. There were not. That's good. It checks to see where it called the manage blocker download image, and it tells where that occurred, and so on and so forth. So the nice thing was it was able to go through the code and answer the questions that I gave it, which was a very powerful technique. We're now going to take a look at a second use of ChatGPT on another class that's part of my assignment. This is the process image class, and I give it pretty much the same prompt as before. I tell it what methods to look for. There are just a few methods here, so it's not as sophisticated and complicated as the fork join crawler we saw before. I tell it to follow the same steps to analyze the code line by line and provide justifications for responses and so on. And then I come up with a new set of questions. Some of them are repeats from before, some of them are new. In particular, I want to do things like check to see if they called submit, which they shouldn't do. Are there any try catch blocks in the code? They shouldn't be, but let's see if they are. Do they use a for loop that's an index-based for loop? Are there places where they made calls they shouldn't have? Are there places where they made calls to methods that are going to be non-thread safe? That's a lot of what they did before. And then I start getting into very specific questions for this class implementation. Above beyond, are they using Java streams anywhere? Does the transform image method in the process image task class directly invoke the make perform transform task factory method or not? And we want to make sure that it does, because that's important for it to do it. Does it call the create new cache item method anywhere? We don't want that to happen. And then this is one of my a couple of my favorite ones, because this shows the power of the static code analysis that ChatGPT can do. I want to see whether or not there's a check for a non-null return value from a method call before passing the result to another method call. So it can see that there's a check for null before passing it on. If there's not a check for null, that's an error. And then here's my favorite one. Is there any use of variable plus equal 1 instead of variable plus plus? And when we look at the code, you'll see there is, in fact, an incorrect use of this. So let's just take a quick look at the code. You'll see that we have this method which fails to check whether or not the return value from get or download image is null. So that should be flagged as an error. And you'll see down here, there is a use of Java streams, which we don't want. So it should flag that. And then finally down here, you can see that this code uses count plus equal 1 instead of count plus plus. And we want that to be flagged as an error too. So once again, we cut and paste this code. And we now go back over to ChatGPT. Let's start a new chat window with a new context. Let's cut and paste our code in there. And once again, it'll go ahead and take a look at the code. We want to make sure it's actually found the methods that we told it to look for. There's only a handful of them now. And now it starts to answer the questions. But first, it's actually going to do a little summary of the code and tell us where the lines occur and what the methods do and so on. That's kind of cool. It's actually reading the comments and making sense of them. Good news, there's no call to submit. That's useful. Is there an access to the M transforms field? There is. That's also good. Was there an access to max depth? Nope, that was good. There are no try catch blocks present. That's good. There was no atomic reference or atomic integer. And then it does find a place where it uses a traditional index-based for loop. We don't want it to use the index-based for loop. So it flags that so we could take points off. And then here's a couple other things that are interesting. You can take a look down here and see, does the transform image method directly invoke the create new cache item method? Yes, it does. It should not do that. Does it directly invoke the make perform transform factory method? Yes, it does. That's good. And then down here, you can see that it doesn't check to see whether the return value for get or download image is non-null before passing it to the transform image method. So it was able to detect that that didn't work. That's a mistake. Points off. And then again, this is my favorite one. Notice how I asked it if it could find an example of variable plus equal 1 instead of variable plus plus. And it found it, even though I used a different name for the variable. So ChatGPT was smart enough to know that the variable name here is just a placeholder to be replaced by the actual variable, what they called it in this case, count plus equal 1, but it should have been count plus plus. So very, very cool features. I could go on because I have lots of other examples, but this will give you a flavor of how to use ChatGPT as a code analysis tool. And there's other things we could do with this. We could ask it to generate code that fixes these bugs in various ways, which is also kind of a neat way to use it. But you can see that this is a means for me to be able to more effectively analyze my students' code. And perhaps more importantly, I can then give this rubric to my graders and TAs, and they can run this also, and we can grade and analyze the student code much more accurately, eliminate a lot of the issues with inter-rater reliability. And naturally, they should still do some spot checking to make sure that if ChatGPT identifies a problem, they should go and make sure that it's actually a problem before they take points off. But it greatly reduces the amount of time and effort and inconsistency we would otherwise have. Once again, fantastic example of the benefits of generative augmented intelligence, using these tools in conjunction with humans to do a more thorough and effective and scalable job at code analysis.